Okay, so today we'll be learning about, in this lesson, triangle congruence. Following in your notebook, this is in Unit 2 on pages 16 and 17. So let's get started. To prove two triangles are congruent, there are 5 ways or conditions. 4 of those being postulates, which are SAS, ASA, SSS, and AAS. The S stands for side and the A stands for angle. And these are just how to prove that two triangles are congruent. And the other way is the theorem is HL. And this is specifically for right triangles. And this stands for hypotenuse leg. So let's take a look at a few examples below. We have this example right here. And on these two triangles, ABC and DEF, there are markings. And what these markings are says that this side right here is congruent to this side. This side with 2 hash marks is congruent to this side with 2 hash marks. And these 3 hash marks is congruent to those hash marks, meaning that that line that the hash marks are drawn on are congruent to the opposite or the congruent triangle provided. So you see, as we said before, you can look at the 4 postulates. And we can tell that this is not a right triangle, so we'll not be using HL. So we'll have to look from these 4. We'll have to look for one that has all 3 sides. So that could be, the best option is SSS, meaning we prove this by 3 sides being congruent to each other. So you have 1 side, 2 sides, 3 sides. So SSS works perfectly. So you come over here and you write SSS. And that triangle ABC is congruent to triangle DEF through SSS. Now let's do some on our own. So are these triangles provided congruent? If yes, how so? So let's look at this triangle right here. We can already see that there's a 1 hash mark on each, meaning that line EC is congruent to AC. If you look above right here, what it's saying has a BC equal or congruent sign to DC, and above it is a line, and that line means a side. So it's saying that side BC right here is congruent to side DC right here. So now we have 2 sides, and we can already eliminate angle side as well as angle side angle. Now all we're left is we can prove is SAS and SSS. We know this because those are the last 2, because we already have 2 sides that we can use to prove, and those are the only ones with it. And we know we can't use HL because it is not a right triangle. Now we're going to have to find either another side or an angle. Now if we look at this equation this 2 triangles right here, we see that they kind of touch right here. And we know that as vertical angles, meaning that those 2 angles right there are congruent to each other. They're also known as kissing. So if we see right here, we have a side, an angle, and a side. So what does that match? So that's saying that yes, this is 2 congruent triangles. But how? And we see a side, angle, side. So we know that it's congruent by SAS. Let's take a look at the one to the right. So we have 2 triangles right here. All the information is provided for us, so now we just have to identify it. So we have angle, angle. So it's saying this side is congruent to this side. And we have this side is congruent to this side. Okay, now let's look over to the left 4 postulates that we have. And that doesn't match anything. And that spells a bad word, which we can use in math to know. If it spells out a bad word, we can't use it. So if it spells ASS or SSA, that's not an option. Meaning that these 2 triangles are not congruent to each other. Okay, so as I said before, if one of the 5 conditions are not met, meaning that if it's not SAS, ASA, SSS, or AAS, or HL, then there's no way to prove the two triangles are congruent. So you will either need another piece of information to complete the triangles, or the triangles are just not congruent. So in this case, all the information was provided for us, so these triangles are just not congruent.